6.2. We're going to talk about the product rule. To figure out how we use the product rule, first we're going to go back to Thursday where we were doing expanding and condensing our exponents. So if I look at 3 to the second times 3 to the third, we are imagining taking 3 to the second and writing out 3 times 3. We're imagining taking 3 to the third and writing 3 times 3 times 3. In total, how many 3's do I have? There's 5 of them. 3 to the fifth power is 243, I want to say. Yes. Same thing with variables, right? If I look at x to the fourth, I'm going to write out 4 x's. And if I look at x to the second, I'm going to write out 2 x's. In total, that gives me 6 x's. So what do we think our rule is? What's our shortcut going to be for multiplying two numbers with the same base? What do we do with those exponents? Read. Yeah, we're going to add them. So when you multiply powers with the same base, which means the bases are both 3 here, the bases are both x here, we add together those exponents. That's what we call the product rule. We're going to really quick refresh our memory on our 4 rules for simplifying exponents. We've had these rules before. We're going to repeat them once more. There are no negative exponents. So just like we did on Friday, we're going to take care of all those negative exponents. There are no exponents equal to 0. So again, that's what we did on Friday. Anything to the 0th power becomes a 1. There are no numbers raised to exponents, which means something like up here, 3 to the fifth, we have to rewrite it as 243. And then each base is written once. So I cannot leave it as x to the fourth times x squared because then there would be 2 x's in that problem. Those are our rules. Any questions? We're going to go through a couple of these on this first page really quickly. So if I look at 2 to the third times 2 to the second, I'm adding together those exponents. What does that make? 2 to the fifth power is 32. Same thing in example 2. My base is negative 3. Make sure that we write that entire thing, negative 3, in the exponents. Then I'm adding 12 plus negative 6 plus, what's the exponent on that last negative 3? Yeah, it's a 1. So plus 1. 12 minus 6 plus 1, that gives me 7. Negative 3 to the 7th power. Now, I cannot leave that number raised to an exponent. So the first thing I'm going to do is figure out what is positive 3 to the 7th power. Positive 3 to the 7th power is a big number, 2,187. But there's a negative in front of that 3. Does anybody remember the rule I told you a couple days ago about how to figure out if this is going to be a positive or negative? Autumn? If the exponent is odd, we put a negative in front of our answer. If the exponent was even, we keep that a positive number. Good? Let's do 2 more. Example 3. What is this going to look like when I start adding these together? X to the... Okay, face the front. Negative what? Negative 3. Perfect. Am I simplified all the way here? No. What do I still have to do to this? To simplify it all the way. I want to follow my rules here. I can't leave a negative exponent. So how do I get rid of a negative exponent? Nope. We're going to bring it down to the bottom. So this will look like 1 over x to the positive 3rd power. Good? Can we do one more? Let's look at example 5. What does example 5 look like? M to the what power? M to the what power? Oops. Wait. Yeah, negative 4. And then how do I finish simplifying that? How do I finish simplifying? Autumn. Perfect. So now our expressions are going to have multiple bases in them. So in this guy, I have coefficients, so the numbers, the regular old numbers, those kind of are the same base. And then I have a's, so that's a second base. I'm going to look only at bases that are the same. So a to the negative 5th and a to the 7th. That gives me a to the what power? A to the 2nd. And then I'm going to leave my negative 8 and my 2. I can multiply those together to get negative 16. So my final answer would be negative 16 a to the 2nd. So that's what it looks like when I have 2 bases. Let's take a look at something with 3 bases. Again, I'm going to do that same thing with my coefficients. So the 2 and the 6 makes 12. Then I'm going to look only at the x's. What do I get when I add together those exponents? Negative 2. And then what about for the y's?
3, 4.
It's going to be a 4 because that first y has an exponent of 1. So 1 plus 3, y to the 4th. Is this finished?
No.
What do I still have to do to it?
Simplify the negative exponent.
That negative exponent's going to go down to the bottom. So 12y to the 4th stays in the top. X to the 2nd goes to the bottom. Any questions on that? 2 more and then we're done. Written differently, but essentially the same exact problem. I'm going to first look at all of my coefficients. So I have a 4, I have a 3, and I have a negative 2. That negative goes with the 2. So 4 times 3 times negative 2, negative 24. How many m's do I have? Well, there's 2 m's, but how m to the what power? Not to the 6th. M to the 3rd, because I'm doing m to the 2nd plus m to the 1st. How many n's?
Negative 2.
Negative 2. How do I simplify? I'm going to do negative 24, m to the 3rd stays there, n to the positive 2nd goes down to the bottom. Any questions on that one? Okay, one more. I'm going to do my coefficients first. 3 and 12 make 36. What about the j's? What happens to the j's? Because what is the exponent? J to the 0th power. 0th. Yep. And then k to the negative 2nd doesn't combine with anything. And then like Monica said, we're going to make this into a 1 here. So 36 times 1 is just 36. And then what happens to the k to the negative 2nd? Goes down to the bottom. Any questions on that? If you remember that little graphic organizer that I gave you on Friday, you can fill in the product rule on there. Now that we have that. And then here is your homework. Did I pause this? Nope.